Hello everyone, my name is Rick Costello from Stockbridge, Massachusetts, and I'm an astronomy artist and astronomy lover. I've been basically studying the universe since basically the moment I could read. Remember as a kid looking up, just driving out of, I remember a couple of times driving just in my car, you know, my father driving, I was as a kid, a young child, just remember looking at the stars and just wondering what they are, and I was just mystified by them, and then ever since I could read, I just started learning about the universe, and I just had this need to really understand what this universe is all about, and you know how we got here and everything, why there's an Earth and why there's a universe, and today I like sharing that passion of mine with others, and I do a lot of public and private telescope viewings around the Berkshires, where I'll just announce it on Facebook where I'm going to be, and people will show up, anywhere from 10 to 100 people will show up to look through the telescopes. And it's kind of my goal in life now is basically to teach people and show people the universe. Because of a health issue I had, and kind of changed my life back in 1998, I was one of 7 people that caught this Australian flu, and I was the only one who survived, and I wasn't supposed to survive. And they told me I was going to die that night and all that, but I didn't, and so now I pretty much devote my life to the universe and explaining it to people. And I also do these astronomy paintings here, and I try to paint the galaxy as accurate as possible. Every star is put on right where it belongs. The craters on the moon are all where they belong, and I started these paintings, the astronomy paintings I started back in 1998. I was working on one painting. It took me 2.5 years to complete, and that painting pretty much saved my life. And since then I've been painting a bunch of different other paintings, and my first painting I sold to NASA. They called me up and they saw one of my paintings and wanted to commission one, so my first sale went to NASA, which was just a really awesome, you know, I was really proud of that moment, that they commissioned a painting. And yeah, so I've been painting, and then you know, I've been doing a few shows. I don't do too many shows with the art, but I'm probably going to start in the next couple of years doing some more shows, getting them out there. And you know, and then telescope shows. You know, I've got 4 different telescopes, and I'll bring them around the Berkshires. Usually just 1 or 2 at a time. And you know, summertime is great because in the summertime we're looking right into the center of the galaxy. So there's a lot to see up in our galaxy: nebulas, star clusters, and you know, the Andromeda galaxy will be up by the end of the summer, and in the early evening sky. And that's pretty much what I do. And you know, we get a lot of people. We get a lot of enthusiasm too, with people looking, especially seeing Saturn for the first time. And I find a lot of people looking through my telescope, it's the first time they've ever looked through a telescope. And so I'm happy at that people get to see Saturn and galaxies and all the great things that are out there to see in our universe and in our galaxy. And to go back to the paintings here, I said each painting is done. I try to make them as accurate as I can of our Milky Way galaxy. And I basically start with the Milky Way band here. In the Milky Way band, I basically use a NASA image. They have a whole sky image of the whole galaxy. So I basically, you know, to put the nebulas in. The nebulas are these dark clouds there, and those are basically clouds of mostly hydrogen, some helium, and trace amounts of other elements from supernova. And these are basically star-forming clouds. And then I basically put the background stars, and then over on top of that, I'll put the constellation stars. And they're very intense to do. Like I said, this painting took me, I think, 1.5 years to do. This painting on my right, it took me about 1 year to do. You know, and it's pretty intense putting every star right where it belongs. It's like doing math. You know, this one has to be here, it has to be this size and everything. But when they're done, I just find them to be very beautiful paintings. I just love looking at them when they're done. And I really wanted to get a sense, or show a sense, of what it's like, you know, for the Earth and Moon to be out in space, and to be within our galaxy with the 400 billion stars or other stars in our galaxy. And as a child, I always had a vision of being out in space and looking back and seeing the Moon and the Earth. And from that vision became my paintings. And I think I kind of captured it somewhat. And so, yeah, that's pretty much what I do with the paintings. And yeah, I'm working on 2 more paintings now, and probably going to take me another year to finish both of these paintings. And that's pretty much what I do with the paintings. And then with my telescoping, you know, like I said, I'll have a group of people show up after I announce it on Facebook usually. I'm probably going to go to Instagram shortly to announce it there. But most people show up, and I'll have the telescope set up, and you know, I'll start showing them things. And you know, as we're showing things, I'll be explaining what we're looking at and different aspects of the universe, which I love doing, talking about the universe. I'll talk about the history of the universe. And you know, the people come up, they'll line up, and while I'm talking, they'll look through the telescope. And like this time of year, one of my favorite years, Jupiter's up right now, which is nice to see, but it's going to be up for a few more weeks before it goes behind the sun. And then there's going to be no planets up until, I think Saturn's going to be the first to rise, and Saturn rises, I believe, in September next year, and Jupiter will rise in October. And we're kind of moving, the planets are kind of shifting to the winter sky now, where the last few years, the last 10 years or so, they've been up in the early evening sky. And for the next, you know, for the next 5 or 6 years, 7 years, they're going to be basically the winter stars, or winter planets. And we won't see any planets at night, except Mars and Venus and Mercury as they orbit rather quickly. But yeah, people show up, and then we'll show them up there. And then, you know, this time of year, there's you know, since we're looking out of the galaxy in the wintertime, in early spring, this is like the galaxy season. A lot of galaxies to see. There's the Virgo cluster is a really cool cluster to see. We're probably on the edge of this cluster. There's a few thousand galaxies that belong to this cluster, but there's you got the Sombrero galaxy, which is a great galaxy to look at, a massive galaxy, and then you have this other Markarian chain of galaxies, kind of like a loop of 6 or 7 galaxies, very beautiful to look at, and many other galaxies to see up in the universe right now. And then you have like the Orion Nebula. You can see it in the early evening, maybe up until 9 o'clock right now, maybe 10 o'clock before it sets. And the Orion Nebula is there's a great cloud of gases to look at, and it's basically about 26 light years across. And inside that cloud are basically thousands of new stars being formed. And around many of those new stars, we see planets being formed around those new stars, new solar systems. And it's really great to look at. And then you have a bunch of globular clusters that are starting to come up, and these are really cool. They're basically balls of hundreds of thousands to millions of stars. Almost looks like a baseball of stars, and they average about maybe 150 light years in diameter. But like I said, it would be packed with hundreds of thousands to over 1 million stars, and these are very old stars. 10 to 12 billion years old, very old stars, and they sit above and below the disk of our galaxy. And there's about 150 of those, but pretty cool to see through a telescope, just all those stars all clumped together. And you know, then you have you know, other things, some star clusters to see, and you got the you know, there's just a lot of beautiful things up there to see, and I just really enjoy showing others that, and I think people really enjoy seeing them, especially you know, I think people have a really good interest in the universe. And I try to provide some knowledge to that. And a lot of the viewing we do, we look at, you know, objects that are very far away from us. Some of the stars, you know, 10, 20, 100, 300 light years away. The farthest stars we can see with the naked eye are roughly 3,000 light years away from us. And those are just massive stars to be so bright for us to see. Like Deneb in the Southern Cross, which is coming up in Cygnus, you know, that star is, you know, 3,200 light years away from us. And just to give you an idea how far a light year is, a light year is, if I had a giant flashlight and I pointed it in the sky and I measured how far that light traveled in 1 year, that light would travel 5,900,000,000,000 miles, or rounded to 6 trillion. I mean, what's 100 billion when you're up that high? So roughly 6 trillion miles in a light year. And the closest star to us, Proxima Centauri, part of the Alpha Centauri star system, which is 3 stars, but the closest star of those 3 stars, Proxima Centauri, is 4.2 light years away from us, and that equals close to 25 trillion miles away from us. just for the closest star. And you get to the whole Milky Way galaxy, our whole Milky Way galaxy is 100,000 light years across in diameter, and it's 1,000 light years thick. You think of it almost like a giant pancake-shaped thing, and it's basically rotating. We're rotating around the galaxy. Our solar system is about 600,000 miles an hour, and it takes about 225 million years to complete one rotation around the galaxy. And we've gone around the galaxy about 18 times in the last 4.5 billion years since our solar system has been formed. And and as we look into the James Webb Telescope and the Hubble Telescope and all these other telescopes that they're using now, they're finding that most stars that we look up in the sky have planets. And if you came back, 20, 30 years ago, we didn't know, we thought planets might be rare, but now we're finding that most stars have planets, especially the second and third generation stars. The first stars were just basically hydrogen and helium, which was formed after the first minute of the Big Bang, or first few seconds actually after the Big Bang. And the whole universe is basically hydrogen and helium, and then they collected in galaxies, and they started forming stars within those galaxies. And then the giant stars, they'd blow themselves up in supernova, and that would fuse those atoms in the star into all the elements up to, to helium, lithium, beryllium, all the way up to uranium with 92 protons, all the natural elements in the universe. And the supernova throws it out in space, and it recollects with more hydrogen atoms in the galaxy, and then later generation stars will form out of that. That remaining star, and new stars will be formed with planets around it, and so it's amazing when you think when our galaxies roughly possibly up to 400 billion stars, and you get to numbers that 400 billion. How do you even comprehend a number like that? When you think of the universe being 13.8 billion years old. I mean, that's time we cannot comprehend. When you think 1 billion years equals 1,000 million years, or 1,000 million years, I'm sorry. 1,000 million years for a billion years to happen. And our solar system is 4.5 billion years old, and our universe is 13.7 billion years old. And it's hard for us to comprehend the amount of time has passed before we're all here. I mean, this universe is very old. And it's still in its infancy. This universe is a good chance it could go on for trillions of years, unless the expansion of our universe continues. Right now, the universe is expanding faster and faster because of dark energy, which is something we don't really know what it is. We have really no idea what it is. We see the effects of it, but it's making the universe expand faster and faster. And if the expansion happens or continues faster and faster, it's going to get to a point in about 50 billion years from now that it's possible that the universe will rip apart. As the universe expands faster and faster, it's going to tear apart galaxies, planets. All the atoms are going to be ripped apart. So we're hoping that it'd be nice if the dark energy manifests itself in another way in the future, where it becomes weaker. Because if not, the universe could end in about 50 billion years and just ripped apart. But now they're seeing more signs that the universe is different in different locations. The speed, there was a feud between the Hubble telescope and other telescopes when they looked at distant galaxies, what the expansion rate is of the universe. And the expansion rate you can think of for every 3.26 million light years, the universe is expanding about 42 miles an hour away from us. So if we're looking at a galaxy 3.2 million light years away from us, that galaxy is moving away from us at about 42 miles per second, I should say. I think I said hours before, per second. And if we look at a galaxy twice that distance, it's moving twice as fast away from us. If we look at a galaxy 5 times that distance, it's moving 5 times faster. If we look at a galaxy 100 times further away, it's moving 100 times faster. And as this progression continues, when you get to the edge of the universe, it appears the farthest galaxies are moving away from us faster than the speed of light. Although they're moving just as fast as our galaxy. If someone was on one of those galaxies, 13 billion light years away from us in the past, I should say, they would see our galaxy moving away from them over the speed of light. But it's just an expansion of the universe. And like I said, it's going to keep speeding up. So we're hoping that something happens to the dark energy where it weakens and kind of stabilizes the universe. And the universe could, if that happens, perhaps the universe can go on for, hundreds of trillions of years before everything breaks down and everything's sucked up in black holes and all that. And so that's kind of like the history of the universe in the long term. But for this term, where we are now, it's just great to see the universe and what the scientists are learning about the universe. The age of the universe and how stars formed, and how all the atoms in our bodies, all the atoms that make all the rocks, all the atoms that make the air we breathe, and the iron in our blood, the calcium in our bones, were all formed in supernova. Like I said, the early universe was basically just hydrogen with one proton, and helium with two protons, and a little lithium with three protons, and then the stars formed, and big stars blow themselves up in supernova, forming all the elements. And so basically we owe our existence to stars, long ago stars in the past, massive stars that ended their lives in supernova, to create the elements that make us up and make up the planets. And without those massive stars, it would be nothing but helium and hydrogen in the universe, which would mean no life and no planets. And I think it's one of the great things to think about, just how everything came to be. You think back billions of years ago, if you look at all the galaxies, how they're expanding away from us, if you play that film in reverse, all the galaxies come to a single point at the same time. So we know at one point, all the matter in the universe was at one point, even though at that time there was no matter, it was just pure energy. When the universe happened, it was basically smaller than an atom, but it was packed with energy with a temperature of thousands of trillions of degrees. And then the Big Bang happened. It was kind of like inflation. The universe kind of went like this, sucked back in, and that equalized the temperature. Then it expanded much faster in light. And then from that, in 1 second, the temperature dropped from thousands of trillions of degrees down to 10 billion degrees. And after three seconds, the temperature dropped to 1 billion degrees. And what that caused with energy, according to Einstein's M equals C2 square. I'm sorry, I think I messed that up. E equals MC square. Is basically matter and energy are the same thing. And matter can be converted to energy, energy to matter. And basically when the temperature dropped from those thousands of degrees, trillions of degrees down to 10 billion degrees, the energy actually froze into particles, quarks. And those quarks, they always group in twos or threes. And and they're different kind of quarks. 6 different flavors, they call them, or different kinds. But two of the kinds, up and down quarks. When you take 2 up quarks and 1 down quark, it makes a proton. And when you take 2 down quarks and 1 up quark, it makes a neutron. And within the first minute of the universe, all the nucleus of all these atoms throughout the whole universe was formed. And from there, the universe continued to expand. And after about 380,000 years after the Big Bang, the universe cooled enough for the nucleus of those atoms to finally catch the electrons. And once that happened, light was able to travel the universe, and we see that light today as a microwave background radiation, which is basically the energy and the light from the Big Bang that was able to travel the universe 380,000 years after the Big Bang. And in the microwave background radiation, you've probably seen that's like the oval picture with the greens and the orange and the reds. And it basically shows the universe as it looked 380,000 years after the Big Bang. And then from there, we can watch the universe age. As we look at galaxies that are 13, well, it's kind of a misnomer there. You'll read that the farthest galaxies we see are 13 or over 13 billion light years away. But it's kind of a misnomer, because when the light left those galaxies over 13 billion years ago, the universe was about a quarter of the size it is now. So those galaxies at that time were maybe 5 to 8 billion light years away from us, maybe a little less than that. And then as the universe has been expanding, it's taken that light 13 billion years to finally catch up to us and to see the universe in the past. And as we look at these galaxies, 13 billion light years away, and then 12 billion light years away, and 11 billion, and 10 billion, and closer, we can actually see and watch the universe age. Because that light from 13 billion years ago is just reaching us now, and as we look at galaxies closer and closer, we can actually see how the universe aged, and that's a great thing with telescopes. Telescopes are time machines that allow us to look back into the past, and you're always looking back into the past. I like saying this: you've never ever seen anything in your life the exact moment that has happened, and that's because light has to travel to you. And even somebody who's standing 3 feet away from you, you're always seeing them 3 billionths of a second ago, as it takes almost in a billionth of a second, light travels almost 12 inches, a little under that, 11.35 inches, I think it is, or 7, I believe it is. And so in a billionth of a second, light travels about a foot. And so if somebody's standing 3 feet away from you, you're always seeing them a 3 billionths of a second ago. If somebody's standing 50 feet away from you, you're seeing them as they looked 50 billionths of a second ago. When we look at the moon, it's taking that light 1.25 seconds to reach us, so we're seeing the moon as it looked 1.25 seconds ago. And as we look at like Jupiter, we're seeing Jupiter as it looked 45 minutes ago, as it's taking that light that long to reach us. And Saturn, we're seeing Saturn as it looked an hour and a half ago, as it's taking that light to reach that long to reach us. And that's the great thing about looking at the universe, is that we can actually see back in time and watch the universe age, and that's how we get our knowledge from the universe, all from light, from the distant past. Now, as we look at these galaxies, the furthest galaxies away from us, we're seeing them as they look over 13 billion years ago. But where those galaxies are today are about 45 billion light years away from us, because the universe is expanding. We see that light as it looked 13 billion years ago, and because the universe is expanding, right now our visible galaxy that we can see is about 26 billion light years in diameter. About 13 billion light years, we have a cone around us that we can see in every direction. But as the universe has been expanding for the last 30 years, those galaxies are getting further and further away from us, but the light hasn't had time to reach us. And to where those galaxies are today, roughly 45 billion light years away from us in every direction, given the universe, a 96 billion light year diameter. It'll take, for us to see those galaxies where they are today, it'll take 45 billion years for that light to reach us. And as the universe expands, there's a good chance, in another 10, probably 25, 30, 40 billion years, those galaxies will be so far away. And that's another thing about the future. I mean, if you go back to, the way our understanding of the universe was, if you go back less than 100 years ago, before 1926, the people of that time thought the whole universe was our Milky Way galaxy, because we didn't have all the best telescopes to see really far distances that time. And they used to see some fuzzy patches. They see like the fuzzy patch of Andromeda, which you can see with your eyes. And they thought these patches were part of our galaxy. And then Edwin Hubble got his 100-inch telescope in Mount Wilson, and he discovered Andromeda was actually another galaxy. And then he found all these other galaxies, and all of a sudden, because of Edwin Hubble, all of a sudden our universe got a lot larger. And we realized that our galaxy is a lot larger than we thought it was back then, and filled with, they estimate now, about 2 trillion galaxies in the visible universe alone. But if you go back to those farthest galaxies, I mean, we can't see past them. But if you were on one of those galaxies, and we have a 13-year-old light year bubble around us, so we can see this far. But if you're in this galaxy, they have their own bubble. So they're probably seeing even more galaxies that we can't see further away from them. And that could go on forever. The whole size of the universe, I mean, we have our visible universe, but the whole universe could be a lot larger than we think. Could be, thousands of times larger than the visible universe. And there actually could be pockets of other universes within this. So they think there's multi-universes out there, some scientists, because of the math kind of brings up that there's other universes out there. Unprovable at this time, but it's possible there's, could be uncountable other universes out there. It could be even universes where, we're sitting in this room in another planet, in another galaxy, in another universe. Because of the repetition of galaxies, you get to a point where it starts repeating itself. And so it could be copies of us in other universes, and it could be uncountable other universes out there. And yeah, so that's basically what I do is I try to teach people and show people the universe. And from my telescope shows, I do a lot of them on Baldwin Hill in Egremont, which is just a great place. You basically have 360-degree horizon to horizon. And for the Berkshires, it's pretty dark up there. We get some really good skies, and we can see galaxies out, with a telescope up to about 80 million light years, which is pretty incredible when you think Andromeda is only 2.5 million light years away from us. So we see a lot of galaxies out, pretty far. But even the galaxies we see maybe 80 million light years away from us, I mean, that's just a small area of the whole universe, which expands for billions and billions of light years. So even through the telescope, you're just seeing a small part of the universe because our universe is just so massive. But so I'll go to like Baldwin Hill up in Egremont, and I also go to the parking lot on New Lenox Road there by the boat launch. That's another nice place to look. And those are my two main places. Occasionally I'll go up to Adams, I can't remember the name of the lake up there. Yeah, but you can find me on Facebook. I usually announce on Facebook, Rick Costello. I think if you hit Great Barrington, I think it has me living there, and even though I don't live in that town, but it's kept it. So Rick Costello and Great Barrington, you can find me on Facebook. And when I take telescope, I'll announce it a day or so in advance, all depending on the clouds, because as everybody knows here, it's cloudy a lot in the Berkshires. I read up here when I first moved that the percentage of cloudiness is about 72% of the time it's cloudy, and living here, we kind of believe that. I'm hoping this summer we get a drought. I probably shouldn't say that, but just so we have clear skies after last summer, which was basically a cloudy summer. Not much telescoping going on last summer, unfortunately. But yeah, I'll be back at those places. I'm hoping to pick some more places up. So if anybody knows any good places that we can have public viewings, please let me know, because I don't know North Country all that well. And so if anybody has any places that we can do a public viewing up there, let me know, and I'll bring the telescope up there. And to contact me, they say you can find me on Facebook, but if you're not on Facebook, you can contact me. I'll have a mailing list that I'll send out when I'm doing viewings. My email is rickcostello8, the number 8, @gmail.com. And you can contact me, and I'll put you on a list. And when I take the telescope out, I'll announce it on the list. So hopefully you can show up for a viewing and check out the universe. It's just a great place to understand and to see too. A lot of great things to see up there in the universe. And so I hope you can join me sometime for a viewing and look at our universe.